we are gonna see the solutions of first internal set B of subject computer oriented numerical methods. This assignment was guided by Dr. Shaligram Prajapat. So let's get into it. So the first question is, find the cube root of 12 using fixed point iteration method, correct up to 4 places of decimal. Okay, so this is a photo of solution which I have solved. So for cube root, we will use the function, this function we are talking here about. Okay, fx equals to 1 by 3, 2x plus 12 by x square. So let's start with the initial guess, x not equals to 0. So we will be putting the value of x not equals to 2, means x0 equals to 2. Then x1 equals to 1 by 3, 2 into 2 plus 12 upon 2 square, which is gonna be 14 by 6, which gonna be equal to 2.3333. Now for the second iteration, we will putting the values of for x2, which is gonna be 1 by 3, 2 into 14 by 6 plus 12 upon 14 by 6 square, which is gonna be, after solving it you will get the answer 2.28999. For the third iteration, we will go with x3 equals to 1 by 3, 2 into 2.28999 plus 12 upon 2.28999. After solving the equation, you will get the answer 2.909, which is very close to 2.28999. So we will take it as an answer. So this was the cube root of 12 by using fixed point iteration method. Now for the second question, write an algorithm, flowchart, Python, C, or MATLAB program for finding square roots of 12 using Newton-Raphson method. So this is the Python program. You can do anything you want. So this is a program which actually works pretty well. So we will start with defining a function, square root of Newton-Raphson, then argument number. Then we will take a variable guess, which is going to be equal to number divided by 2.0, which is going to be our initial guess. Next, for in range 10, guess equals to 0.5 into guess plus number divided by guess. This is the formula of Newton-Raphson formula. Okay, then we will return the value of guess. Then if name equals main, then number to find the square root, we have to find the square root of 12, right? Here it is. So then we will find the square root, which is going to be equal to Newton-Raphson formula. We are talking about this formula. Then we're going to print the value, the square root of number to find the square root, which is 12 apparently, is approximately square. This value is going to print in the output screen, and this is going to be the right answer. So let's move on to the next question, which is give the output of Gauss-Jordan algorithm for this matrix. Here we are talking about this one. This is the matrix and we have to find the output using Gauss-Jordan's algorithm. We have also talked about this question in the previous video. Go check it out. Then okay, so let's start. First, begin with the augmented matrix presented in the system of linear equation or the matrix to be inverted. This is already in the augmented form. Forward elimination, back substitution, solution attraction, or inverse calculation. So basically in the Gauss-Jordan algorithm, we have to do, we make all these diagonal numbers, this and this one with by using elementary row transformations, and all the other numbers like this triangle right here equals to 0, and this triangle right here equals to 0. This is called upper and lower triangles of a matrix. Then we will compare its value to, then we will compare the values of these ones to these values, and they become our answer. So let's get dive into the question right away. Now this is the matrix which was given, and we will perform operations like this inside of the matrix, and we will write its output here, and we will perform it multiple times. until we get something like this. As you can see here, diagonal values are 1, 1, 1, 1, and everything else is 0, and we are getting these values as answers. So we will just compare it. So after doing all that, we will get the values of w, x, y, and z. So w's value is 1.209, y value is 3.077, x values is minus 1.548, and z's value is 1.433. uh, thanks for the thanks for watching the whole video.